Hello, hello. The topic of today's lesson is we're looking at triangles and exploring their angles, but we're going to look at angles outside of triangles or any other shape. They have a special name, exterior angles. Exterior angles. Exterior angles. Let's look at where they're located. If you are to extend a side of a shape into a line that goes on forever. Notice how it creates an angle with another side. This angle in geometry is called, is called exterior. This angle is called exterior. And I think we can guess why this is called exterior, because it's external to the shape, opposite of angle A, angle B, and this tiny angle C, it's not that tiny, are all called interior angles. And I think we understand why this is called interior, why they are called interior angles. Interior angles, because they are inside the triangle, inside the shape. By the way, any shape can have exterior and interior angles. And today we're talking only about triangles. So here is an interesting part, my friends. Exterior angles are special, and they're special in multiple ways. They become very useful when we're trying to find missing angles inside the shape, and when we're trying to build larger shapes out of our triangles. But today, we're only going to learn one part about them, one special part about them, that the size of the exterior angle is actually the sum of interior angles that lay on the opposite side. So let's consider interior angles here. We have three interior angles. We have interior angle A, interior angle B, and interior angle C. However, the exterior angle, I'm going to highlight it lime green. This angle is the same size as the sum of the interior opposite angles, and only angles A and B are opposite. So this particular angle, exterior angle, equals to the sum of interior opposite angle A and interior opposite angle B. So this angle is called angle ACE. Let me trace angle ACE. Which one can I take? I'm going to take a nice orange. So angle ACE is equal to the sum of interior opposite angles A and B. So let's practice this, because sometimes it's not very clear until you start really practicing this different concept. So we have a new triangle. Let's take a look at problem number 8. We have a triangle that's called XYZ. I hope you know how to properly name triangles. We go from X to Y to Z. And YZ, the side YZ, is extended to point B. YZ is extended to point B. So let's do this. YZ is extended to point P, creating a new angle. I'm going to stick with my colors. I'm going to stick with lime green, creating angle XZP. So it's from X to Z and to P. So this is the exterior angles. This is the exterior angle, XZP. So given the two opposite interior angles, can we find the exterior angle, the angle on the outside? Of course we can. It's quite simple. If we add 50 degrees plus 34 degrees, the sum of the external angle XZP will be 87 degrees. Next, in each figure, let's practice some more at the bottom of page 127. In each figure, ACD is a straight line. Let's label it. I love labeling straight lines. In geometry in general, when you read something that is given, please take a moment to find it on the given drawing. So ACD is a straight line. ACD is a straight line. And on the next triangle, ACD is a straight line, creating, I'm going to use my lime green color, creating these exterior angles in their respective shapes. So exterior angle meaning laying outside of the shape. So find unknown mark angles. Well, let's take a look at first triangle and angle A. We do have a small symbol for the right angle. So this angle is equal 90 degrees plus 43 degrees. The math is so simple, 133 degrees. And that's, my friend, that's how simple it is. Now, in the following problem, we are given the exterior angle. Here's our exterior angle, and that equals 210 degrees. We know one angle is 50. How can we find the missing angle? Well, I hope you understand that only 60 and 50 inside the triangle will give us a side and exterior angle of 110. I'm going to extend this problem. How can we find this angle formed by a straight line if one side is 110? Last week and in previous lesson we learned angles on a straight line add up to 180 degrees. So if the entire angle is 180 degrees, what is the missing side? Well, I hope you realize 180 minus 110 equals 70 degrees. So this angle is 70 degrees. Now, can we take a look? Does 70 plus 50 plus 60, does it give us 180 degrees? Yes, all angles in a triangle add up to 180 degrees. Now let's go back to the previous exercise. If angles on a straight line, right here, right? Let's pick up purple. If all of these angles must add up to 180 degrees. We learned that angles on a straight line add up to 180 degrees. We learned it in previous angle lesson. And one of them is 133. Can we figure out the missing angle? Let's go. 180 minus 133 equals, well, 180 minus 130 is 50, minus 3 more, 47 degrees. This piece is 47 degrees. Now, let's check the rule of triangles. 47 degrees plus the two known angles. It's given one is 90, it's given one is 43. Does this add up to 180? Well, yes, we have a 90 degree and these two add to 90. So 90 and 90 gives us 180. Voila, everything is proven. Thank you so much. I hope it clears up your understanding of exterior angles. We will use them in subsequent exercises finding missing angles.